My
This
name is
conference will now be recorded.
Hello everyone. My name is Wei Feng from Famic Technologies in Canada. So today I'm happy to connect with all the Philippine authorities, teachers, and friends, and also our partner High Tech Power. And today I'm going to present a topic regarding cultivating sustainable quality technology education in the new normal. Since the pandemic, the whole world is in a different phase. We do different education, we do different teaching and learning. So Famic technology provide a very good solution to help the world to adapt to this new environment. So today I will start from the webinar and from our company. So first, I introduce our company a little bit, and we were founded in 1986. Globally, we have more than 130 engineers, and we're headquartered in Montreal, Canada. I'm based in Canada. I'm the regional manager for the Asian regions, and I manage a team here in Montreal and in our Pune office. And our mission is to satisfy each territory's education needs with our fantastic innovative solution. So our expertise is completely software development to develop a software for the pneumatic, hydraulic, electrical, and automation systems. And with this, and we have four solutions for the market. We have the industrial used professional edition automation studio. We also have automation studio educational editions and the manifold for industry and a studio for industry 4.0. And right now in Philippines, we have already a lot of clients using automation studio, and we are happy to see the good feedback from them. And so our software and has a long history, and the company was founded in 1986, and we published the first pneumatic simulation software called the NewSim, the HydroSim software, and we combined them together called Automation Studio and based on Windows system. Then with the computer evolution, slowly we add different modulars. Right now, we came to Automation Studio 7.0 and provide a really good new education tool for this new normals. So today I'm going to show and how it works and how our software can help the new normal education. So our software includes many technologies. We put everything in one software, and you can see the typical hydraulic, pneumatic, electrical, and PLC automations. And our software is widely used in educational work like mechanical, electrical, mechatronics, automation, also for industry like mining, construction, agriculture. So students can learn virtually from home, and the schools can teach all the technology and in one software, and they can present to different departments. They can share the budget, and during the pandemic, teachers can teach the software and teach the technology in a virtual platform without going to the lab, and they don't have to open the lab. They can use the software. So, and we also have some exercise embedded in the software. Students can learn, can practice on it. And it's a virtual, right now I think hardware is a little bit difficult to get. And now we have the virtual software. So we have network licenses, so students can practice at home, and teachers can teach from home, and it's online, and they can interact with each other to learn different technologies, PLCs, electrical, pneumatics, everything in electronics and automation. So there are different markets like technical high schools, workforce development, vocational centers, technical colleges, universities, and so on. And so we have a lot of industrial clients in agriculture. We have like AGCO, construction, Caterpillar, mining. We have John Deere, and transportation. We have Honda, and so on. So we have a lot of manufacturers catalogs, including the hydraulic, pneumatic, and electrical components, for example, Mitsubishi and Eaton, and so on. So I'm going to show the software and to take a few examples that you feel the real like feeling how we teach and in this new norm, and how our software is a very good has a very good quality, provide a quality education. So the first thing is, in one software we put all technology together, and you can click jobs, do whatever you want. For example, for the mechatronics and the pneumatic is a typical subject. You just open and to see, for example, teachers need to teach the symbol, and so take the symbol. So traditionally, teachers use PowerPoint, use PDF to teach symbols. Right now, we have a large library, and the teachers can teach all the different type of cylinders. Now, and we can take others and to build the circuits. This is component level. Now, also we can teach, different level is this level, like we use the different like component together, and exhaust, I put everything together, and so we just connect them together, and I connect this one. So we can easily build a circuit. You can customize it. So that's why, real, like, there's no lab right now. There's all students can practice at home with the software, and then they start simulation to learn how it works. This, and then you can see how the circuit works, how this component works. I change the parameter, for example. Then we can see the speed is slower, and this shows the function of this registration from this component, and the direction and control can be viewed and taught from this component. So this is how we like teach different parameters, and technically it's not a flash media, and it's customizable and based on your course curriculum, and you can do whatever you want. You can see the parameters of different components, and it's very easy for you to learn different technologies, phenomena, and so on. So this is a way, and we try to improve the teaching process and learning process. And also teachers can customize component properties here. They can adjust the different symbols very easily. There is a library. You can change anything, and to customize the component. Now here's the one technology, and now you want to connect it with another technology. For example, we have the electrical. So at the same time, we provide electrical circuits, and I can show you the circuit we created. And for example, I put a simple electrical circuit at the same time, and I put the solenoid here, and very easily, and you can connect different technologies. And so now the electrical circuit is the same as pneumatic. You draw them, then you can connect this one, double click, and you can connect this one with everything from the electrical circuit, connect them together, and you start a simulation, and you can click, electrical circuit will activate, and to switch very easily, connect electrical. So this is what we teach different two technologies together. If we go another level, and let me see more complicated, and for example, for the electrotechnical. So in this environment, and I go to another library, I switch it, and in this one, the same thing, I can create a AC/DC circuit. For example, I have a power source. Let me see. Oh, I take electrical. I think here we go. So the same library, we have all the energy source, power, energy converter, transformer, motor starter, protections, and so on. And we can put this one here, and put one this here, the fuse, and also I put AC motor. In this case, and we can connect the circuit directly in the electrical circuit. In this circuits, and we start a simulation, and you click, you can see the animation. So this is the motor change. If you increase the load, you see the speed of variation, and also you can measure the current in the wire, and also you measure the voltage between these two nodes, and you increase the torque, you see different parameter change. Also for students, and they can use different measuring instrument, for example the multimeter, and so he can choose different like a multimeter to see different parameters like this. Also the clamping motor, multimeter clamp. So by using this, and the teachers can measure different parameters in the circuits. And also there's oscilloscope. This oscilloscope give you a virtual idea how it works, how to detect different parameters in the circuits. And so in this case, and people, students and teachers can learn the series of the circuits completely. For example, I put different activate a different channel. I put it here. I put this one here. I put this one. This is one phase, and you see we can see different phase, and we can see the different phase. Like this one, different phase. And if I put the two together, auto scale, and you can see the different like a phase like a different the between the phase wire 1, wire 2, you see the different phase, and you have the different cursor, different position to see and how it works. So in this way, schools doesn't have to be worried that these instruments can be broken, but the teachers can teach different concepts for the AC circuits. So this is another like a level we want to bring and the teaching to a new and innovative norm. So now I close this part. So as I turn it off, so this AC circuits and we created. Now I also want to analyze, do some technical things. You can double click and to see the data. There are many data you can modify in each component. This is the same as pneumatic I showed you here. If you go to pneumatic and if you double click one component, and you can see different parameters. So you can always change and you can see the effect right away. And for example, for this case, we have the cylinder, we extend the cylinder and make it bigger. For example, I increase the cylinder stroke a little bit bigger. So I think we do different parameters. So I just changed the technical parameters in this symbol. And you see we start, you see the speed, it takes longer to reach because it's longer. And we can also make it faster, and but you can put a lot of controls on the parameters. This is the same for the electrical, and you have different parameters for this motor, and you can change them and in these parameters. So now next, this is AC circuit. If we go into the circuit a little bit more about the DC circuits, and we can just change some parameters and put it here. And I have some, like for example, the coil. Coil, yeah. And we also have the resistor. So all those AC circuits I show you here, and that we connect them all together, and then I can start a simulation. Let me see the parameter, the km, and it's too big. I just change the parameter. Let me keep the big one. I'll show you how it happened. If this parameter is not correct, this is the rated voltage 240, and I start the simulation. You see, there it doesn't work, and so let me see if there's any current inside. So very small, and so this one, it should change the state as this AC circuit change. You see, they turn right. The reason why it didn't work just because the parameter is not correct. So in this case, you can change the parameters and we start a simulation still, and I will change this one. I put this 1 ohm to 1 ohm, a smaller one. SG. Now it open. Now you disconnect, connect. So you see the state changes. So this gives us a better way and to understand your circuit and understand the different series and in the simulation mode. Now, and I connected the AC control, the DC circuit to control this electrical circuits to control the motor. So we can go here to go to a motor, for example, a contact pole, this one, and for example here. But I use this DC circuit to control it, and again, very easily, we connect this with this KI. I will build connections. Now it doesn't work. Now activate this part. Now I put the control from the DC circuit on the AC circuit. This is how this works. So, and we have this solution, and you see the build controls, different systems, and very easily, and so that everyone can see different features and system interaction in a simulation mode. Teachers can teach and to use it, and students can practice, and then they exchange idea, and then it's a remote and more innovative education. So this gives teachers and students more access to knowledge. Our knowledge is condensed in the component itself and of the series. If you want to learn some equations, and we also have the equations and all the equations here, and you can build and you can validate these equations here. You can build different series, for example, and so I can choose, for example, the output is here is this value, and we choose different parameters, and we can change the different parameters and then transfer back. Transfer back, I think, is too much. Let's see. Yeah, transfer back everything, and then you can want everything updated. Then everything can be inside. Then you can use this one to validate your equation. This is a way, and we teach all this. Now there's other things. Now we come back to the circuit troubleshooting. Right now everything is fine. Teachers can do some troubleshooting things. For example, we have the troubleshooting failure tool. I just cut the wire and activate the wire. Now you see it lost the power, lost the connection, and you know it how it works. You don't have to break your hardware equipment, but in the software environment, you can trigger different failure mode, and then now you can do some analysis. So we can analyze the circuit with this kind of like, for example, the multimeter. We can test is it battery broken? No, battery is working very well. this wire is working very well, and this coil is working very well, and this wire, oh, you see, it's not working well because it stands all the voltage. Now you can repair it, and now this wire is broken. So everything goes normal. So this troubleshooting function, our software provides you a very good environment to learn the theoretical exercise and everything you need to do, and it's very impressive. And then, so this is the part we are trying to do to learn different circuits, different symbol technology, different symbols in different technologies. And at the same time, we have others, for example, the PLC. You can learn the PLC ladder and use PLC to control it. For example, and I want to use the PLC to control this directional valves. So we replace this, and for the PLCs, we have different standards. For example, here, we have the PLC, we have different component, and also we have different like PLC card, input card, output card. And also we have different controls on the push button and a push button and solenoid. The same thing. I put it here and I push different like for example in. I put it here and the solenoid out, and so I connect this one with different symbols with this one, and I connect with this one, and I connect this one with this one. The same philosophy for the PLC card, and then we can connect build a ladder, PLC ladder. So I believe a lot of like colleges, universities train PLCs, teach PLCs. So we provide you a way to train PLC in a different approach. Everything you want to train in your school, teaching in your school is programming. But you never have such a nice object to control, and pneumatic and electrotechnical, the motors, everything. So let's see the sequence here. So now we use this one to control, very easy. This one in 0, go here, very easy. We just control the in 0, and I connect this one. And this one out, we connect with this one, out 1, connect with out, connect. And then we connect the solenoid with this solenoid again. Let's go here, and it's OL. We connect them together. And now you can see the electrical control. I think I may make a wrong connection. Yeah, I make a wrong connection. Let's see. You see the solenoid, this one. I think, let me see the problem. Maybe it's this one. It's the problem is doesn't activate. So Alt 1, oh, Alt 0. This is Alt 0. So this is the problem. I'm sorry, I cannot say anything, but I made a mistake. Now you can see the arrow. It's not on purpose. Today I just made a mistake. But when your students make a mistake, they can see the simulation right away. They can validate the theory. Now I click this one. Okay, so let me see. Alt 0 and sorry, Alt 0 is this one. I think I make another mistake. Alt 0 with Alt. Alt with this one with the solenoid. Okay. This one should connect with this one. I rename it a little bit. Now I fix the problem. So you see, I click this one.
This conference will now be recorded.
Now here, I just want to continue this presentation. And here, I think we needed to connect this Alt 0 with Alt, and connect it with this one. And we start simulation. Click, you see it's connected, and it runs well in this case. So this way is a PLC. We put PLC controls, and also it can connect with pneumatics, connect with the electrical circuits, and then you can start stop simulation. Now we have this this tool to provide a simulation, controls, everything together, and then also for the symbols. Also, we have another new library, and we can provide we call it illustrated components. And if we click here, you see with different illustrated libraries. We have the electrical, we have the renewable energy, we have the residential electricity, and so on. For example, PLCs, we just finished PLC. We have different options of PLC cards. For example, Siemens PLCs like this one, and for example, i7 1200, and put it here, and you can replace this card with this PLCs. In this case, you can build a more real looking PLCs and do the wiring instead of this symbol. So this is another like symbol. We call it illustrated library, and you can teach different technologies in the different illustrated library. Let me open some examples. You can see. So, for example, renewable energy right now is a popular technology everywhere, and you can see different components, everything like this. It's the same. You can drag drop component, put everything together, and then you can see how it works. Now I get some points like from the some real project to share with you. So the first one is the PLCs. Let me see. We have the S7, Siemens S7 1200 PLC to control pneumatic with this illustrated library. The PLC is used to control the sequence of the different cylinders, different components, and start a simulation. And start the same thing. You can see the different reaction. So you see, right now I have a more complicated PLC logic, and everything is controlled. This is a sensor, this is a pneumatic, and this is PLC ladder. This is the PLC input-output cards. So in our software, we include all different, all the complete symbols, also the illustrated libraries. This is one thing, and we created, and also I show another thing is electric. Also, not only for PLCs, for the electrical components, we also have illustrated electrical component. The same thing, dragged up from the library and build a circuit. And here is a comparison between two circuits. And one is PLC and another one is illustrated. One is the AC circuit, another one is illustrated components. So in this case, you can push button and play the circuits. You can see how it works. And the same thing, you have different symbols in this illustrated library. And you can see the different parameters. And you can stop. You see the different wires. The same idea, but this is more illustrated. You can change the speed, the load, the torque. Start simulation. So in this case, you can, let me see. Yeah, you see the all lines is with color. How you increase? You can increase during simulation. The same thing here in the library. You also can increase the torque. You see the different variation of parameters and so on. So this is one thing, and for the illustrated library. And another thing, I'm go back to this project, and I get another illustrated library. Now I am going to show you the hydraulic, and I know hydraulic is not that a common course anymore in Philippines, but we have a complete hydraulic library too. So we start a simulation, and you can see the same thing. You can see how different circuits works, and also you have the illustrated library. You can see this with the flow and with the component, how it works, what a real motor, what a real cylinder looks like, and also you have this. This is some like interesting things, and we are showing to different libraries, symbols, and for people to teach, for teachers to teach, for students to learn. And also we have a library called the Catalog Manager. With this one, and for educational, and we include a lot of teaching material from industry. For example, we have the complete material and to teach different manufacturers catalogs. For example, I show you something. For example, the Bosch. Bosch is the largest hydraulic component manufacturer. So hydraulics, and you can click to open to see. So in this case, we have a very nice 3D for the component. For example, this is a common pressure relief valve, and we want to teach students what a relief valve looks like. And for this cartridge valve, this particular one, so you can see different like the 3D, and we can change the options. This is the one type, and this is another type. This is the difference. In this case, you can use our software to teach different type of components with the 3Ds and very illustrated, and students can learn very fast. So, and this gives you a lot of flexibility and to teach and put all the document together and to teach different components. So also, for example, I show you another example or typical for the hydraulics, for example. We have a very, for example, if you teach mobile highway machinery for excavators, wheel loaders, trucks, we also have very good components to teach. For example, we take one example from like a Bosch exhaust again. We have a large library of different manufacturers. And for example, I take this one and here. So in the library, and you can teach, for example, I teach you what a pump is. And I take a Bosch exhaust one, and I take one component from here, and we have a test bench to show how this component, this piston pump works. So in this case, we built a training material from the industrial, and this is a piston pump, this is a motor, and this is a very commonly used component for mobile machinery, for example, excavators, and for the ships, for the trucks, for the mining equipment, tractors, and so on. And you can use this one to increase the change the flow. You can see the flow during the operation. You can put a load on the motor. You can see the pressure variation. So it's very easy for you to teach all the theories in the hydraulics, and you don't have to build anything. You just open, click, all comes out. So this gives you a lot of teaching material, the big library, big database to teach different things. Students can learn by themselves, and it's a really good information for them to learn, to explore. There's instructions. It's very illustrated how this component works, and the teachers you don't have to use the flash. You just open the different components, and you can reuse them all the time. So this is another typical example, and I want to show for hydraulics. Another thing I try to share with everyone is we also have a very good 3D. The 3D example I want to provide, and for example, today is aerospace and example. And we are this example I shared is we connect all the 2D with the 3Ds. And because 3D right now is very popular everywhere and it's very visualized, then no one can connect the 2D and the 3D. And in our software, we have the 3D part to connect this 2D hydraulic circuit to the control. You can see very easily. This is a typical landing gear. And this is one case. And I also have another one to share with you is, let me see this, another 3D for the factory. What I see, let me open. Let me open this. Just wait a little bit. Yeah, put it in the middle. This is used for factory. So we have the 3D and connect with, we have HMI, and we connect, we use this HMI to control the 3D, control the pneumatic circuits and the PLCs, electrical, put everyone together. So in this case, to teach different technologies in one software, and you can see how it works, and you can see the different technology interact with each other. So this is a 3D, and those materials and are built in, and you can get them from our website, and you can build, connect them easily. You can customize them, and it's not something you really cannot work on it. So this allows you to allow students to practice, to learn how 3D works, because it's more visual and students can learn different aspects in the 3D. And for the 2D parts, and together they can learn everything. So here is the panel. The panel, we have the library for this panel. You can build your panel and drag drop. I just show a little bit from the panel. We have this library called HMI at the bottom. This library have all the components, and you have all the buttons, and you can drag drop with them here. So you can customize HMI panels to control your machinery, make it really look like a virtual digital twin solution for your hardware, for your projects, to teach different things. And besides, we have some like electrical catalogs. So the electrical catalogs shows you the, for example, the variable frequency. Let me see if I can have a variable frequency. So if I open the electrical technique, the motor drives, let me see. I take VFD from Allen Bradley, Power Flex. So while it's loading, I show the example in our like website. So you can download all the catalogs from here. For example, I mentioned all the VFDs here we have. We have many VFDs. There are a lot of VFD variable frequency drive, Allen Bradley, and we have Mitsubishi. We also have Omron, and we also have Siemens, Yaskawa, and so on. So in this case, I show you one example here. This is Allen Bradley, and example, you can download everything and to reuse in your teaching. So this is the motor control to control the motor with the variable frequency drive. First, you can teach this forward, stop, reverse. See the speed animation. There are different types of VFDs you can really build here. And for us, it's very easy for teachers to take from the catalog, and I just put it here. I see it's electrical. And all those material and I showed today is shareable with our clients and always teachers globally, and you can download and you can study, you can learn, and everything is shareable. So we spent years building this catalogs and this teaching materials for our clients with industrial expertise from industry and also from global teachers from United States, from France, from Germany, from China, from Japan. And we collected all the feedback. We built different teaching materials. And let me go to the forum we have. If you go to our website, go to forum. So you can download everything from education session. And so we have different files, for example, from PLCs. So you can download all the files also. And so you can learn very easily for you. Also, you can share. If you are our clients using our software, you can create a circuit and post them regularly. And let me see. So those training material we have, for example, we have the motors, we have motor soft starters, variable frequency drive. So the drives we just shared with Alan Bradley, maybe use Siemens Small. There is Siemens Simatic. What you have to do, you can configure it here from different voltage and different setups, and then close. It's the same as the library. It is in a different library. Let's create a new project. I configure it, and so I open a new one, and then you can put it here. So you can configure it here and then put it in the circuit. You can draw, you can connect what you need from the in your real application. So in this case, also there is a database here, the teaching material. You just open and don't save it and open it. This is another circuit and for you to use to build the VFD. In this VFD, we have many parameters you can choose, select, and you can work on. So this is a VFD circuit, and we have a plotter to plot the performance of the circuits. And do it. You have different options for here. and to manage. You can change the settings, everything. You have different options. You have different options to design it. So this gives you a lot of flexibility to design the circuits. So, and we have this one. This is the circuit you are going to use. And I have another one example, and maybe the last thing we share with you is we have other examples here. Power, and we have soft starter. Different, for example, ABB soft starter. Also here you can configure it and build a soft starter. So we put different brands together to create a nice circuit to show how it works, let people understand our concept. So this is the soft starter, and you have the nice circuit to reuse. You can modify everything in the circuit. So I think this all I want to explain today, and I'm happy to share our solutions, and I'm happy to listen to your feedback. And if you have any questions, please contact our partner, High Tech Power, and I think they can give you a nice support. And we are happy to see Philippine friends to know know more about Automation Studio, to learn and to use them. And I'm happy to see you. Thank you a lot. Thank you. Bye.